Once again, good morning, everyone. I would invite Arun sir to start the session.
Sure, ma'am.
Thank you, sir.
Good morning, everyone. This week, syllabus is relative velocity and kinematics under variable acceleration. Alright. So let's start with kinematics and variable acceleration and come back to relative velocity again under the concept of variable acceleration. Okay. Now, I've got if I get x of t position as a function of time, then I know the motion of the particle. Because if I know x of t, I know v of t, which is dx by dt. If I know b, I know a, which is dv by dt. I can also know a by v dv by dx. Alright? These are derivative forms of equation. Okay, I need to write bigger. Right. Now, let's integrate. I've got v is equal to dx by dt. So dx is equal to v dt. I integrate on both sides from t naught to t, from x naught to x. So I get delta x is equal to.
Sir, your camera is blurred.
Okay.
Yeah, now it is focused, sir.
Who's wanted? It's over here. It's over.
Yeah, okay.
Thank you, ma'am.
Yes, sir. And write somewhat big, sir.
All right, ma'am. Sure, ma'am. Dx by dt is v. So dx is equal to v dt. I integrate at, let's say, t naught, position is x naught. At time t, the position is x. So I'll get delta x, which is x minus x naught. Integral v dt from t naught to t. Alright? So this is one equation. So given v as a function of t, I can get delta x. Or I can get x as a function of t by x minus x naught as integral v dt. So if x is given as a function of t, I can get v by differentiating it. But if v is given as a function of t, I can integrate it and get x from this equation. Similarly, I'll use second equation now, a equal to dv dt, and I'll get dv is equal to a dt, t naught, v naught, at t it's v. So v minus v naught is equal to integral a dt, t naught to t. If a is given as a function of t, I can get v as a function of t. Similarly, I'll use the third equation. I'll get v dv is equal to a dx, integrating it from x naught, v naught, x, and v. So I'll get v square minus v naught square is equal to 2 integral a dx from x naught to x. If a is given as a function of x, then I can get v as like this. Right? If v is given as a function of x, I'll get a as v dv dx. But if a is given as a function of x, I'll get b as b square minus u square as 2as. Let's say if a is constant. What if it's a is constant? Then I get from equation, this equation I get v is equal to v naught plus a integral dt from let's say 0 to t, which is v naught plus at. I get basic kinematic equation. If a is constant, from this equation I get v square minus u square into 2as. V square is equal to v naught square plus 2 integral a dx from 0 to x, let's say. So v square is equal to v naught square plus 2a x. Again, a basic kinematic equation. Okay. And if I write v as dx by dt, then I'll get x is equal to v naught t plus half at square. Basic kinematic equation. So when the acceleration is constant, we get these from these integrals itself. These variable acceleration becomes constant. If a is constant, then a comes out of the integral. We get constant acceleration equations, which are these v equal to plus 80, s equal to u plus half a t square, and v square minus u square is 2s. Alright, these are the equations we get. But if a is variable, and as a function of t, I use this equation. From here I integrate. A is equal to dv by dt, dv is equal to a dt, v minus v naught is integral t naught to t a dt. Correct? This is one equation I use. If a is given as a function of x, I use third equation. A is equal to v dv by dx. So v dv is equal to v dv is equal to a dx. Integrating v square by 2 minus v naught square by 2 is equal to integral a dx. 2 goes on that side. I get v square minus u square x 2 integral a dx from x out to x. Alright. So now, given a function, we should be able to get x ultimately. But once I get v, from there I get v as dx by dt and further integrate. Let us look into an example and let's see how do we get v x from given an a. Given a as a function of t or v, how do I get x as a function of t? Ultimately, required is x as a function of t. Alright, can I erase it? Any doubts here?
No, sir.
Alright. Let us take this third equation first, v dv by dx, and solve x as a function of t. I've got a graph in which velocity is varying like this. V as a function of x is varying like this. And I told you that this has to be a dotted line as x approaches x naught. Why it has to be a dotted line, you'll understand now. Alright? Vx naught cannot cut x axis with v is equal to 0 at x is equal to 0. So x is equal to x naught. Alright, it cannot cut x axis like this. The straight line cannot cut x axis, a vx graph. Sorry, a straight line cannot cut x axis in a vx graph. Alright? So you'll understand why it's supposed to be a dotted line now. All I told was it has to be a dotted line, it cannot be a continuous line to x naught. It approaches x naught but doesn't cut x naught. Right? Let's see how. Now, which equation do you think I should use? Given this v as a function of x. So should I use a is equal to dv by dt or a is equal to v dv by dx? I'll use. So let's chat here. Okay. So I use A is equal to V dv by dx. Because V is given as a function of x here. I first get V as a function of x. I need to get the equation of line. How do I get the equation of line? Slope intercept form. Can you tell me the equation of this line? V is equal to as a function of x. Is this correct? I could be wrong, but is this correct? Slope is minus v naught by x naught plus intercept v naught. Y intercept. Y is equal to mx plus c. Is the equation okay? Is the equation understood?
Yes, sir.
Sir, can you
Okay.
please explain?
Yeah, sure. See, equation the line, I've written it like this. Use slope intercept form. What is the slope of this equation? V naught by x naught is tan of this theta. V naught by x naught. But I want this tan of opposite angle, which is negative V naught by x naught. So y is equal to slope into x plus c, where c is y intercept. Here it is v naught. Slope is minus v naught by x naught. So my equation of line becomes y is equal to minus v naught by x naught x plus v naught, where y is v. So that's my equation of line. Or I can write y2 minus 1 by x2 minus x1 into x minus x1. That equation also I can use. I'll write y x1 y1, x2 y2, y minus y1 is equal to m into x minus x1. I can use that form as well. But I found this is easier than that, so I explained this as I can use anything. Either I can write y is equal to mx plus c form, is the same thing, or I'll get the same equation, or I can write as y2 minus y1, y minus y1 is equal to y2 minus y1 by x2 minus x into x minus x1. Alright, these two forms I can use to get the equation of line. Alright, now once I got the equation of line, I plug this equation of line over here. So what is it? A is equal to no, I want x as a function of t, right? So what I do, I use dv by dt. I got b as a function of time. If you're using a is equal to b dv x, I get acceleration. What is the acceleration I get? I differentiate this. I first write this v naught by x naught, x plus v naught into slope dv by dx, which is minus v naught by x naught, which is equal to v naught square by x naught square, x minus v naught square by x naught is my acceleration as a function of time, as a function of x. Look at this. Acceleration is linearly varying with respect to x, and that is proportional to x. And as x is increasing, my acceleration is increasing. As x increases, acceleration increases, linearly increases with x. If I plot this function, but I'm not done yet. I'm getting a as a function of x. Ultimately, I want x as a function of t to get the motion. Once I get x as a function of t, I can differentiate and get b as a function of t. Alright. So to get x as a function of t, let's see what we'll do, but I'll just plot this one. y is equal to mx plus c. M is positive, b square by x square is positive, x. So y is equal to mx is positive line like this, minus 3, negative intercept. A equal to 0, x is equal to x naught. Alright, this is the acceleration versus x graph. But I want x versus t graph. Ultimately, I want x as a function of t. So what I'll do, I'll use this equation and substitute v is equal to dx by dt here. I'll write v is equal to dx by dt for this second equation and solve further, integrate further. Alright, let's see how we integrate. Integration is simple, but there are standard integrals which you have to remember. So I can write this as v naught into 1 minus x by x naught is dx by dt. Alright, now look at this. What I do, this is just as a function of x. Now understand this integral here. I mean, it's not nothing to understand, but you have to get used to this integral. I've got this integral, I've got this differential equation where dx by dt is equal to v naught into 1 minus x by x naught. RHS is only a function of x, right? This is only a function of x. I have dx by dt is equal to f of x. So what if I can write this equation as dx by f of x is equal to dt and integrate on both sides. I can integrate this equation, right? Because this is only a function of x. With respect to x, I can integrate. This constant here 1, which I can integrate with respect to time. Right? So I can integrate this, right? This is what I'm going to do here. I'll take this function on the left hand side. I'll write dx by f of x and integrate it from certain limits. So I've got dx by 1 minus x by x naught is equal to v naught dt. I integrate. At t equal to 0, my position is 0. At t equal to t, my position is x. Alright, look at the way I substitute the limits. Corresponding limits. At t equal to 0, my position is 0. Alright, it started from origin. My particle started from origin. And at t equal to t, at some time t, my position is x. It's along the straight line. Particle is over here. It started at velocity v naught, moving towards x naught. Now look at this, as it is moving towards x naught, my acceleration is negative, it is being retarded. How can I say my acceleration is negative? You have seen the graph just now. My acceleration x graph is v is positive, x is 0 here, so it is moving towards x naught. But acceleration is negative. Velocity is positive here at a position x, but acceleration is negative. Look at this graph. V is positive, but acceleration is negative. So acceleration is towards left, velocity is towards right. So particle is retarding. So at time t equal to 0, particle is at 0. At some time t, my particle is at distance x, position x from origin. Alright, that's how I written this equation. I'll repeat. I realize this unnecessary part. I've got v is equal to minus v naught, so v naught into 1 minus x by x naught, which can be written as dx by dt, is equal to, so if I take this as a function of x, I take this whole function towards denominator on the left hand side, I get dx by 1 minus x by x naught is equal to v naught into dt. I integrate on both sides. At t equal to 0, my position is 0. At t equal to t, my position is x. Alright, that's how I got this equation. And if you just understand the motion, particle is retarding. So ultimately, it's supposed to stop here at x naught. How can I say it's supposed to stop here at x naught from Vx graph? V is becoming 0 as x is tending to x naught. As x is tending to x naught, V is tending to 0. And acceleration is negative throughout. Till x naught, acceleration is negative. But acceleration is also reducing. If it was a particle can cross x naught, it will accelerate. Because once it crosses x naught, my acceleration is positive. So it will further go away. It will accelerate. It will go away to infinity. But it has not crossed x naught yet. So it has to cross it to accelerate further. But it has not crossed x naught. It's still on the left of x naught. In that case, acceleration is always negative and the particle is always retarding. So from here to here, initial velocity is v naught, but acceleration is negative and particle is retarding towards x naught. Alright, so 1D motion. We are talking about 1D motion only. Otherwise, the graph doesn't make sense. Alright, graph makes sense only in 1D motion. Alright. Okay, now let's integrate this. How do I integrate this? I take this LCM here, x naught, and x naught goes on numerator. So I'll get x naught dx by x naught minus x is equal to integral v naught dt 0, 0, t and x. Alright, this is important how you write the integral. At t equal to 0, position is x, 0. At t equal to 0, it's at origin. At t equal to t, it is at x. Alright. So I am studying the motion from 0 to x naught and writing the function of x as a function of t. That's what I get ultimately. See, right hand side is dt, left hand side is dx. I get, when I solve this integral, I get x as a function of t. Okay, now x naught, let's say x naught goes over there. Now look at this. If I multiply with minus 1 on both sides, if I multiply with minus 1 on both sides, what is this integral? This integral is line integral, which is integral f dash is by fx dx. What is integral f dash is by fx dx? ln f of x or log the base e f of x is this integral. Alright, this is the formula which I am using from integration. Don't worry if you don't know this formula. This is standard formula which we are going to use again and again. Integral f dash is by fx dx is ln x f of x log mod f of x. Alright, now look at this. So I can write this integral as log x naught minus x under the limits 0 to x is equal to, the constant comes out minus p naught by x naught, integral dt is t under limits 0 to t. Till here, from graph I got the equation. That equation I have written as dx by dt. Dx by dt I have taken the f of x on the right hand side to the left hand side in the denominator. I got dx by f of x is equal to v dt in something as a function of t I integrate this. To integrate this, I'm using this formula. Integral f dash by f x is log mod f of x. I will say f dash x. If I differentiate this one, x naught minus x, I get minus 1. So this is nothing but f dash x by f of x. If this is f of x naught minus of x is f of x, derivative of that is minus 1. Because this derivative of x naught is constant, derivative of minus x is minus 1. So derivative of the denominator is minus 1. So I'm getting the form as f dash by f of x. This is the standard form which we come across repeatedly. Alright. So I'll integrate this. Now after integrating, I'll substitute the limits. So I'll erase this part. Base e x naught minus x, the limits 0 to x is equal to minus b naught by x naught t. Alright. I substitute x first and then I substitute 0. So log e x naught minus x minus log to the base e x naught minus 0 is equal to minus v naught by x naught into t. So log a minus log b would be log a by b. Log x naught minus x by x naught is equal to minus v naught by x naught into t. So if I take the exponentiate both LHS and RHS, I get x naught minus x by x naught is equal to e power minus v naught by x naught into t. So 1 minus x by x naught is equal to e power minus v naught by x naught into t. So rearranging, x is equal to x naught into 1 minus e power minus v naught by x naught into t. This is what I'm getting x as a function of time. Alright. This function, this integral, this graph, we get repeated in mechanics. Alright. This is a very important problem. This function, this graph, and this integral f dash to fx, we get repeated in mechanics. Alright, that's why I'm making you do this problem first. Alright, now, any problem as of now? So I got x as a function of t, we need to plot x as a function of t. Once I get x as a function of t, I'll differentiate it, I'll get b as a function of t. Alright, so let's plot this. Is it clear, students? Is it clear as still here? All I did was integral, mathematics. I didn't do anything, any physics till now. Now let's understand the graph and answer the physical situation. But till now, what we've done was rearranging equations, integrating it, substituting the limits, and getting x as a function of t. Alright, is it okay as of now? Any doubts so far?
Sir, can you explain once again?
Yeah, sure. Who is it?
Preeti, sir.
Preeti.
Yes, sir.
Alright. Yeah, sure. Look at this. I got a function, I got a graph. whose equation was v naught by x naught into x minus v naught, sorry, plus v naught. Right? This graph you have understood. Right? This is the first step. In the second step, I've written v as dx by dt. Alright?
Okay, sir.
In the first step, I took this to the LHS, dt to the RHS, and I've written dx by 1 minus x by x naught is equal to v naught into dt. This was the third step. Integrating it from 0 to t and 0 to x. At t equal to 0, position is x, 0. At t equal to t, position is x. At t equal to 0, its position is 0. At t equal to t, position is x. I integrate this one. To integrate this one, I use that formula, integral f dash x by fx. Which I get log mod fx. That was step 4. From step 4, it is just mathematics. Once I integrate that, I substitute the limits. Look at this. I got this as a function. Log mod f of x. Log x naught minus x and limit 0 to x is equal to v naught by x naught. Integral dt is nothing but t.
Okay, sir.
I will substitute the limits. I substitute the upper limit first. Upper limit, if I substitute x, I get this one. If I substitute the lower limit, I get this one. Log a minus log b is log a by b.
Yes, sir.
Is equal to v naught by x naught into t. That is simple. Now I exponentiate on both sides. I take e power of this one and e power of this one. Not send e power e to that side. I get e power of v naught by x naught into t is equal to log of this one. Log of this one is equal to this. So e power of this one is equal to x minus x naught by x. X naught minus x by x, sorry. Alright. Now I rearrange this equation. I rearrange it. Rearranging this equation, I get x as a function of t. That's what I did. So step 1 was write the equation of graph equal to dx by dt, integrate it, substitute the limits, rearrange it, you get x as a function of t.
Okay, sir. Thank you.
Most welcome. Okay. Now let's start this one. X as a function of t I've got. V as a function of t would be differentiating this dx by dt, which is this is a constant, this becomes 0, this becomes v naught by x naught into e. Can you differentiate this and tell me? Yeah, it's a good exercise. Differentiate and tell me. Differentiation is done. Alright, basic math, e power ax, derivative of e power ax with respect to x. What is it? Chain rule. E power ax into a. Right? So similarly, you got minus e power ax here. So minus e power ax into a is a derivative of this one. X naught is a constant. Derivative of a constant is 0. Alright? So I get v as a function of x as v naught by x naught. Sorry, v naught into e power v naught by x naught into t. This is get as a v as a function of t. Let us plot both these curves and let's see how is the particle moving. Let's plot v as a function of t first. It is very simple. V is equal to e power minus ax. How is graph e power x graph? E power x graph is like this, exponentially increasing. E power minus x graph would be exponentially decreasing like this. So this is e power minus ax graph. So I'll get v as a function of x as starts with velocity v naught, increases asymptotically as t tends to infinity. It will never become 0, but tends to 0. It will never stop. Particle will never stop. So it keeps moving towards x naught, but slowly and slowly. Its speed goes on reducing further and further because the acceleration is negative. acceleration towards left, particle is retarding. So it move towards x naught, but never reach x naught. That's what this says. Okay, speed never becomes zero. That's what this says. Charge velocity v naught, positive velocity v naught is pointed towards right. Acceleration is negative, slope is negative, but the slope is going on increasing. Right? So acceleration is reducing, but there is still acceleration. So particle is retarding further and further, and the retardation is reducing. Now let's start x as a function of time. This was b as a function of time. So b naught into e power minus v naught by x naught into t. Alright, the graph is not complete, but yeah, still we have got some information. Now let's start this one. X naught into 1 minus e power at t equal to 0. What is the value of x? We started with x is equal to 0, right? So substitute t equal to 0 here. E power 0 is 1. 1 minus 1, so 0. Particle charges 0. At t tends to infinity, this tends to 0. E power minus infinity tends to 0. At t tends to infinity, x tends to infinity, e power minus x tends to 0. Asymptotically to 0. So t tends to infinity, this tends to 0. So x tends to x naught. Alright, we could have done transformation using the parent function. Parent function is e power x. From there we could have transformed it. That also we'll do later, right, when time comes, but not now. We don't have time for that right now. We'll definitely do that using transformation. But I just started this graph. At t equal to 0, it is x naught. At t equal to infinity, it is this. It is an exponential function. Asymptotic to x naught. X is y equal to x naught. So it asymptotically increases towards y is equal to x naught. I mean x is equal to x naught. Y axis is x. So t x axis is t. So this is how x is. Look at how x is varying. Particle is never crossing x naught. It is only approaching x naught. So this particle reaches x naught and doesn't stop there. It stops. It doesn't stop at all. It is approaching x naught. There is a fundamental significance of this situation. But right now, understand that particle is just approaching x naught and it's not reaching x naught. It is asymptotically approaching x naught. It will never cross x naught. That is why you have got a dotted line here. Alright, it will never reach x naught. It just approaches x naught asymptotically. That means as t increases, x approaches further and further. X approaches to x naught further as t increases. As t tends to infinity, x tends to x naught, but it will never reach x naught because it's going to reach asymptotically. Alright, e power minus x is an asymptotic graph. You have an asymptote to the graph. Alright. Okay. Now, see, since I got v equal to v equal to f of x, a straight line passing through x naught, but doesn't intersect x naught. If I extend this line like this, and I project the particle from let's say 2x naught with a velocity of negative v naught, I have to plot x as a function of time. Alright, as a homework, you do this. What's the homework? I plot this particle, project this particle. Now I project it from x naught, x is equal to 0 with velocity v naught towards x naught. And now I project this particle towards x naught with velocity minus v naught towards x naught again from 2x naught. X is equal to projected particle towards x naught, but now from x is equal to 2x naught, I'm projecting the particle again with velocity v naught, but towards x naught from 2x naught. So what will happen? Particle is somewhere here. So acceleration is, velocity is negative, acceleration is positive. The particle is again retarded. Again, I've got a dotted line here. Particle will approach x naught, but never reach x naught. So you'll again get an asymptotic function. In that case, what you're supposed to get is particle should come from 2x naught to x naught like this. Alright, this is the graph you're supposed to get. But try to get this graph. Alright, equation also you'll get it from the graph itself because I've shown you the graph, you can write the equation as well. But your homework is project this particle from 2x naught towards x naught with velocity v naught. What happens eventually? Acceleration is towards right, particle is retarding, but as particle is approaching x naught, its retardation is also decreasing. So it's retarding but decreasing. Retardation is decreasing. Its velocity is negative and remains negative, but it never becomes zero. That's what you have seen from the graph, Vx graph. So x should be similar to this. It should start from 2x naught, but tend to x naught and stop at x naught. It doesn't stop at x naught, it tends to x naught. It never crosses x naught. Alright, you understand the homework, students? All you have to do is, I'll tell you what to do also. All you have to do is change the limits. When integrating, I substitute the limits at 0, it was 0, at t, it was x. Now here I substitute 2x naught and minus v naught. That's it. At, sorry. At t equal to 0, I substitute, so that's 2x naught. That's what I do. Nothing more than that. At t equal to 0, I substitute x equal to 0 initially, in the first case, previous case, the case which I solved. But the case of homework, I substitute t equal to 0, I substitute x is equal to 2x naught. Because my particle is starting at 2x naught. Alright, that's why I told you, take care of how you write how you mention the limits, how you read the limits. I integrate, this is dt, this is dx, f of x dx, or dx by f of x. When t equal to 0, initial position is x is equal to 2x naught, because my project is a particle to 2x naught. At t equal to t, position is some x. Alright, similarly in velocity limits, what will I substitute? At t equal to 0, my velocity is minus v naught. In this case, my velocity was v towards right, in the first case. But in this case, my velocity is towards left, so that will be minus v naught. But I don't have to do that because if I get x, I can differentiate it. Differentiating x is easy, integrating is very difficult, but differentiating is easy. So once you get x, you can differentiate and get v. Alright? Is it clear, student? Is the problem clear? Is the variable acceleration where v is varying as x function of x clear? How do I get x as a function of t, q and vx graph? Is it clear?
Yes, sir.
Okay. How about others? Bhavna, Omkar, Vashini,
Yes, sir.
Divya. Bhavna, are you sure it's clear?
Yes, sir.
Any subtle doubt you've got?
No, sir.
Alright, good. Now let's go to the homework problems. I've given two homework problems, right? Two picks. One curve, W-shaped curve.
Yes, sir.
Have you tried it?
Yes, sir.
Okay. Have you tried Vignesh?
Yes, sir.
Okay. Any idea you got of how to do?
Sir, I got on. Yes, sir.
Sorry?
20 meter per second, sir.
Okay. 20 minutes per second. Let me check the answer. Uh, how did you do it? Like, what's your procedure?
1 minute, sir.
Yeah. Others can read the problem till then. Do you want me to send the problem again? Yeah, I send it again. it's an interesting problem where the particles distance variation is given, but distance measured from some fixed point. But the particle is thrown vertically upwards. For a particle thrown vertically upwards, we know the graph is supposed to be a parabola. Yeah, Vignesh, you want to mention how do you approach the problem?
Yeah, sir.
Yeah.
Here S1 equal to 6 root 5 na, sir. T equal to 0.
Okay.
T equal to 0, it reaches the distance 6 root 5.
Okay.
As we take a number line, a vertical line.
Okay.
Here t equal to 0, it means it will be a circle. Circle means any point on the circle.
Uh-huh.
We don't know the direction. I mean, we know that it will goes up like on vertical direction, but as we take a circle, it will be any point on the circle. But if we take bottom of the circle, I mean semicircle, below the line, it will see, sir, as we draw a line on straight line point and circle 2, it will gives us time will increases but not decreases. Here we need to be decrease the time, because s1 equal to 6 root 5, it decreases to minimum s equal to 3, sorry, s3 equal to 6. So we need to be take on the point on the circle on the upside. So as we draw a point from straight line 2 on the cycle point on the circle, it will be 6 root 5.
Okay. Vignesh,
And
whenever you solve a problem, you better what you do is you take a pic of the problem and send it to the WhatsApp number.
okay,
Alright,
sir.
so that I can check. Alright. So today's homework, you do it that way. You solve it, whatever you solve it, because see, there is one more method of solving this problem. I was saying that you could also get another idea to solve the problem, right? There will be multiple methods to solve a problem. So నేనేం చేస్తానంటే you might get another idea. So I was listening to your idea. So whenever you solve a homework, take a pic and send it to the WhatsApp number. I'll definitely check it. Okay, Vignesh.
Yes, sir.
Okay. Okay. You're almost there, Vignesh. I don't remember the answer. Let me check the answer. But you're almost there. I get your point. But why did you draw the circle over there? What is the point of drawing a circle over there?
So we
Now
don't
just
know that.
Vignesh, give me the problem and think about it. Okay, Bhavna thinks you have to differentiate. Okay. Okay, I'll tell you why not to differentiate, but that's also a good idea. Yeah, Vignesh, why did you draw the circle over there? Everything is fine except the circle. Why did you draw the circle over there?
Sir, here if we draw a circle,
Huh?
it will means here time is decreasing, sir, from s1 to s3.
It's anyway increasing. Time is progressive.
Yeah, sir, but in vertical line we don't get the time will decrease or increases.
Okay.
Here t1 equal to we take as a center. From center we are throwing a stone to upwards. It means it will go in the direction that will decreases the time also at the time.
Okay. Your diagram geometry is almost perfect. Except the circle, I don't understand the circle. But okay, we'll discuss it again. Vignesh,
Okay.
I really appreciate this. Let's check the answer as well. Alright, I'll solve the problem. I don't remember the answer, but I'll check the answer now. Alright,
Okay, sir.
Vignesh,
Okay, sir.
I highly appreciate your approach. But have you understood today's homework? I'm projecting a particle from x is equal to h naught towards x naught with the velocity of v naught. Required to find x as a function of time. I've already plotted the x as a function of time for you as a solution. This is the solution, but you have to get the equation. Alright, now let's look at this question. Look at this. We know, see, it's supposed to be a parabola if my point of origin is along the line of motion. Distance traveled, they're differentiating distance traveled will give me speed, but not differentiating any distance. Yeah, Bhavana, I am answering your question. Bhavana says if we differentiate, we'll get the answer, but we don't know the equation first of all. To differentiate, I need to know the equation. But again, I cannot differentiate because let us say a particle is moving in a semicircle. Alright, let us say particle is moving on a semicircle. When it's moving on a semicircle with constant speed v naught, its distance from center is constant, which is radius. Distance from center is constant. So if I plot distance from center, it will be constant r. Distance s measured from center with the function of time, it is constant r. So can I say velocity is zero, speed is zero because distance is zero. Sorry, distance is constant. It is distance measured from center, it is constant along a semicircle. But can I say speed is constant? Sorry, speed is zero because distance is remaining constant? No, because distance traveled or distance traveled, derivative of that is speed. And I measure that distance from some point to the line. So when I measure the particle vertically upwards and I measure the distance from any point on the line, I get a parabol. Not this biquadratic. I get a parabola, quadratic. But I'm getting a biquadratic. That means something is special. I'm measuring the distance from other point, which how Vignesh has measured. Vignesh, I tell you how Vignesh has measured. I'm measuring distance from some other point, but not point on the line. Do you understand this point? If I were to measure the distance from the point on the line, I would get a parabola. Right? But I'm not getting a parabola, that means I'm measuring distance from some other point. As in circle, distance is actually v naught into t. It's a linear, but distance measured from circle is constant. But that doesn't mean my speed is zero. I can differentiate distance traveled, not any measured distance. If I differentiate distance traveled, then it is zero. But this is not distance traveled. It's the distance measured from a point. At that point, if I can locate, I'm done. Let us see how. Particle is projected, let's say from here, with velocity v naught. And let's say I'm measuring not from on this line. I'm measuring not distance not from a point on the line of motion, but some point off the line of motion. Let's say this point. P. So maximum distances, initial distance is 6 root 5. So t equal to 0 is the distance of 6 root 5. Right? 6 root 5. This is 10. This is 6. What is the minimum distance of this point from this line? Perpendicular distance. So this is 6. That means if the particle reaches at this point, at time t equal to whatever time, this is 6. Relative velocity v naught, I get this height as x1. From here it goes further, distance increases to 10. Why am I measuring, why am I saying that this plot is from a point which is off the line of motion? Because if it were along the line of motion, I would get a parabolic curve, a curve with a parabolic nature, which I can differentiate and get the velocity. But this is not distance traveled, this is just distance measured from a certain point. And that point is supposed to be off the line of motion, not on the line of motion, right? If it were on the line of motion, then the graph would be of parabolic nature, but it's biquadratic. It's not quadratic, it's biquadratic. Okay, this curve is biquadratic. Now, something of that sort. Now, look at this. If P is a point off this line, initial T at equals to 6 root 5, minimum is 6, and again, local maxima is 10. So I can say that particle is projected upward, distance of 6 root 5, approach the minimum distance 6, went further up, distance become 10. So if this is 10, this is 6, this will be 8. If this is 6, this is 6 root 5, this will be how much? How much would x2 be? x1 be?
12, sir.
12, sure. not sure, 6 root 5. So that becomes
180, sir. 180.
yeah, right. Correct, that is right. 6 root 5 square minus 6 square under root. 6 root 5 square minus 6 square under root. It is 6 into root 4, which is 6 into 2, which is 12. That's what you said, right? Is it clear? Now look at this, what is happening. If a particular particular velocity V0, it went up, crossed this point, went up again to 10, came back to 6 over here, and came back to 6 root 5. So it is maximum height is 20. Maximum height reached is 20, right? 12 plus 8 is maximum height reached. So v square by 2g is equal to 20. So v0 square is equal to 20 into 20. Let's take g as 10. Right? Given g as 10. V is equal to 20 meters per second. Was that your answer, Vignesh?
Yes, sir.
That's absolutely right. Everything was perfect. And you have done the same thing. V square minus u square is 2as. U square is 400. U has 20. That's absolutely right. Except the thing, the circle I will mention, but the point was absolutely right. That's perfect. This is the previous Olympiad problem, students. I really appreciate Vignesh. Vignesh, you have done an excellent job solving the problem.
Thank you, sir.
Right. Have you understood, Bhavna? Have you understood why we are not supposed to differentiate?
Yes, sir.
Differentiate just I should differentiate the distance traveled, not distance measured from some point. Distance not measured from a point along the line, but it's measured from a point off the line. Okay, let's check that the graph is not parabolic. If this were parabolic of quadratic nature, then this would be a graph from a distance measured from a point which is on the line of motion. अपने आप parabolic वस्तुंडे, but it's not parabolic. This is some other biquadratic form. That means my distance is measured from off the line, not the line of motion, but off the line of motion. So let's say point P. At t equals 0 to 6 root 5, and minimum distance is 6. It crosses this minimum, goes to maximum height, distance becomes 10, comes back to 6, and comes back to initial position, and goes further. So this graph goes further like this. Alright?
Yes, sir.
Everyone, have you understood Gayatri, Omkar, Varshini, Divya? I don't see other names.
Yes, sir.
Okay, alright. Alright, students, if you don't have any doubts, please put forward. And any question, anything you saw, please send it to the WhatsApp number. Alright, I'll check personally. Alright. And next, so we'll do the same thing, we'll solve some more problems in the next class. But this week we have got relative velocity and variable acceleration as the syllabus. Relative velocity in 1 dimension and 2 dimension, and 2 dimension no, only the minimum distance problems. And we have got variable acceleration as syllabus. Alright, thank you all. And I hope you remember the homework. Please try to do the homework, send it to the WhatsApp number. Thank you all. Thank you, ma'am.
Thank you, sir.
Have a great day,
Yes.
everyone.
Yes, students, now you can join 6 to 7 link. Please join the next link, that is 6 to 7.